Welcome all. This is Dr. CVR Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Today we are here to learn searching techniques, especially linear search. So before understanding what is linear search, let us try to define what is searching. Searching is the process of retrieving a specific element known as key element in a given list of elements. So, in a given list of elements, we are trying to check whether the key element present or not. If that element is present, then we will consider this operation as successful, otherwise unsuccessful search. The most extensively used searching algorithms are linear search and binary search. Linear search working principle. In linear search, we will try to search the key element presence in a sequential order. First, we have to traverse the elements using a loop. In each iteration of the loop, compare the search element, that is nothing but the key element, with the current element. If that element is found, that means if that element matches, then return the index of the corresponding array element. Otherwise, that is, if the element does not match, then move to the next element. If and continue this process till we exhaust the list. If there is no match or the search element is not present in the given array, then return -1, which indicates that this searching operation is unsuccessful. So here we'll try to understand the linear search using an example. Here we are having a list of elements. In this list we are having 5 elements, 5 numbers, randomly picked numbers, and we are trying to search a key element which is 1 in this particular example. So here key value is equivalent to 1 and we are trying to compare that key element with the first element of the list. Here the key element is 1 and the current element is 2. So the match is not, there is no match. So we will go with the next iteration. That means we will compare the key element 1 with the second element 4. Here key is not equivalent to the current element. Then we move forward, we move further, we'll try to compare the next element with the key element. Here also the key element is not equivalent to the current element. Then we will go with the next iteration. Here the next element is 1. That is the current element is 1. And the key element which we are searching, that is also 1. So here the key element is equivalent to the current element. So here we got the element which we are trying to search. In this case, we will display the position of the key element which we found in this operation. So here the position of that particular key element is 4. Generally, the indices will start in any programming language with 0, 1, 2, 3 and 4. But human readable indexes are 1, 2, 3, 4 and 5. So here the index is 3, but the location at which we found that element is 4th location. So here our searching algorithm must display 4 as the location of the key element. Suppose if we are searching for 8, in this list if we are searching for 8, then So here our key element k is equivalent to 8. Now we'll try to compare our key element with the first element. Here key is not equivalent to the current element. We'll go with the second element. Here also the same case. The key element doesn't match the current element. Next, compare with third element, then fourth element, and then fifth element. Even after comparing with the last element, the key element is we could not find the key element, which is 8 in the given list. So here we reached the last index and there are no other elements to compare with. So here we will stop the searching operation and we will display -1 as the result, which indicates that it is an unsuccessful search. That is, the key element is not found in the list. So here implementation of linear search in Python. How do we implement linear search operation using Python programming language? The first statement, A is equivalent to a list of some elements. Here, for simplicity, we are considering integer list. So, A is equivalent to 23, 54, 70, 56 and then 29. And key element is equivalent to 29. So, here A is a list of the elements and key is the element which we want to search. And n is equivalent to length of A. That is nothing but the size of the list. Here the size of the list is 5. Now result is equivalent to linear search. Here we are calling the method function linear search by providing the parameters A, the list of elements, n, the size of the list, and key, the element which we want to find. So we are passing these parameters to the function linear search and the outcome of this particular function or the return value of this particular function is assigned to result. So now the result will hold either the position of the key element or else -1. So if the result is equivalent to -1, then the key element is not found. It is an unsuccessful search. If it is not equivalent to -1, any other number which is not -1, then it indicates the position. That means the search operation is successful and we will try to display the index at which we found that particular element. So this is how we are going to develop a Python code for linear search. But the statement here we are calling the method and we have not defined that particular functionality in this slide. So now let us try to implement linear search method. So we are providing the definition for linear search here. So whenever we are writing functions, we will make use of the keyword def, defining a function. Here the name of the function is linear search and my list is the list of elements, n is the size of the list and k is the key element. And when we are passing the parameters, they are the formal parameters. They are the actual parameters and those are A, N and key. A, N and key. Here A will be transferred to my list, N will be transferred to N and K will be transferred to K. Here we can make use of the same names of the actual parameters or else we can have a different list of names to the formal parameters. Here N, both actual and formal parameter is having the same name but other two parameters having different names A and K. So my list holds list A and K holds the key element. So After getting those parameters, we are running a loop according to our algorithm which we discussed in the earlier slides for I in range 0 to n. So when you take this range method, it will start from 0th index. In this particular range method, it will start from 0th index till n minus 1. N is exclusive. So it will take the indices from 0 to n minus 1. If my list is nothing but the list which we are considering, that is 23, 54, 70, 23, 54, 70, and then 56 and 29. 56 and 29. This is list A. So this is the list, and the indices for this list are 0, 1, 2, 3 and 4, starting from 0 to 4. And here the name of this list is, in the function definition, the name of list is my list. The name of the list is my list. So if my list of 0, that is 23, if it is equivalent to the key element k, that is nothing but 29, or key element is 29. If it is equivalent to the current element, then we are returning the position I. Here the position is 0. Otherwise what we are going to do, here we will go with the next iteration. So here 23 is not equivalent to 29. So we'll go to the next iteration, and in the next iteration the I value will be 1 and my list of I will be 54. Now we will compare 54 with 29. If 54 is equivalent to 29, then the search is successful. But here both the values differ. Then we will go with the next element 70, next iteration. I is equivalent to 2 now, and we will compare my list of 2 with the key element 29. Here also match is not found. Once again we will go with the next element 56 against 29. We will compare. Again it doesn't match. We'll go with the next iteration. Now I is equivalent to 4. So my list of 4 is equivalent to 29. My list of 4 is equivalent to 29, and k is equivalent to 29. So here 29 matches the key element 29. So what we are doing now, when the current element is equivalent to the key element, we are returning I. What is I here? It is 4. It is 4. The position, the index actually, the index of the current element, which is a match with the key element. Here we are returning I. So when it returns I in the driver code, here the result is not equivalent to -1. The result is equivalent to 4. So here the element is found at index 4 we are going to display. Okay, if you want the absolute position, then you can write result plus 1. Then we have to write at location, not as index. Element found at index. If we give this comment, then we have to write the exact index value, that is 4. The element found, if you write element found at location, then we will write result plus 1, which is the position of that particular element in the given list. It is a human readable format. Okay, so suppose if we are trying to find for some element 35, which represent the unsuccessful search, then once again we'll start from the first index, that is my list of 0. We'll compare 35 with 23. It doesn't match. Then we'll go with the next iteration. I takes value 1. We'll compare 54 with 35. No match. Next I becomes 2. We'll go with next iteration. 70. We'll compare 70 with 35. Next, again it is not matching the key element. Next I becomes 3. Next iteration 56. Now we'll compare 56 with 35. No match. Again I takes value 4. Now here also the key element doesn't match the current element. Now I value becomes 5. When I becomes 5, automatically we will come out of the loop, and we will come out of the loop and we will return -1. We will return -1, which indicates it is an unsuccessful search. So when the key element is not found, we are returning -1. When the key element is found, we are returning the exact index of the key element at which we found. This is how we are going to implement a linear search using Python programming language. The same thing, here we are trying to implement linear search using C code, C programming language. Here also we do the same thing, but here the syntax difference from Python to C. Here we are trying to give the entire program with the output and all. So let us try to understand each and every statement present in this particular C program. In this one, we are giving array of 100. That means here we are declaring an array which can hold 100 elements and a key variable which in which we will store the element which we want to search. This is for iteration purpose, iterative variable I, and n is to hold the size of the list. So 4 variables here we are declaring. In C language, we have to decide all the variables. We need to declare all the variables whichever we are going to use in our program. So here all the 4 variables are declared in the first statement. After that, here we are taking an arbitrary size 100. The user may want to store 5 numbers or 10 numbers depending on the user's choice, but he cannot exceed more than 100 elements. He cannot store more than 100 elements. So here we are asking the user, enter the number of elements in array or else how many elements you want to store. Such kind of comments we can give through the printf statement, and we are reading that input through the scanf %d ampersand n. Here we are getting the size of the array from the user. We can check the same thing here. Enter the number of elements in the array. Here the user entered 5. So after taking this input, we are giving the same thing. After taking the input, we are asking the user to enter 5 integers because he entered 5 as the input. So after after giving this message to the user, we will try to read 5 different elements in this particular scenario, 5 different elements entered by the user. We are trying to read 5 different elements entered by the user. So to read 5 different elements, we are writing a scanf statement. Here we are reading each element in the array by writing ampersand array of I, and we are placing this scanf statement in a for loop because we want to run this particular statement for 5 times because the size of the array is 5. If it is 10, then we will go with 10. Here the size is stored in n because this is the value which is entered by the it is the value which is entered by the user. So here we are reading 5 different elements. After getting 5 different elements into the array, then we are displaying that list. Then we are asking the user to enter the key element which he wants to find in the list. Enter a number to search, and we are accessing the key element which we want to find. So here the user entered the key element as 4. So in the list, the first element is 5, and then 6, and then 4, 2, and 9. That is the list. So here 4 is present in at the index 2 and location 3. So this output we have to give. So up to this, the code is explained here, and to display this particular output, we'll write that part in the next slide. So here we got the input and we know the element which we want to search in the list. To check whether that element is present in the list or not, we are writing this part of the code, and in this one we are running a for loop which traverses the list, which is having 5 different elements and 4 in the second index. Some element is here, some elements are here. So this is 0th index, first index, second, third, and then fourth. This is how the list is, and we are trying to figure out whether 4 is present in this list or not. For that we are writing this loop starting from 0 and up to n minus 1 exactly. So if array of I, in this for loop we are writing an if statement. If array of I, that is nothing but what is the initial value for I? It is 0. So array of 0 is equivalent to key. What is the element that is stored in the first location? Maybe that is 5, I think. So is 5 is equivalent to, here it is not k, it is key. Is it array of I is equivalent to key? No. So when it is not equivalent to key, then we will go with the next iteration without executing the if block, because the condition fails in the first iteration. Now we will go with the second iteration. Now I value is 1. Array of 1. If array of 1 is equivalent to key, that is nothing but the second element. If it is equivalent to key, then we will try to execute the if true block. Here in this iteration also the key element is not equivalent to the current element. Then we will go with the next iteration. Now I is equivalent to 2. When I is 2, array of I is equivalent to the key element. Here 4 matches are key element. So when there is a match, then this block will be executed, this true block will be executed. So when this condition is true, then only this true block will be executed. So here what we are trying to do? We are trying to display the location. So printf percentage that is nothing but a placeholder for the key element. 4 is present at location C plus 1. At location. So when I say at location, then index plus 1. So C is nothing but, here it is not C, it is I. I plus 1. I plus 1. I is 2 plus 1. That is 3. So 4 is present at location 3. And we are executing a break statement after printing this message. So when there is a break statement, when that break statement encountered, then automatically it will terminate the loop. So after terminating the loop, I am checking whether C is equivalent to N or not. Here it is not C, it is I. If I is equivalent to N or not. So here in this case I is 2. What is N? It is 5. Is it equivalent to I? N is I equivalent to n? No. So when it is no, then we are not going to display this one. So why should we check this one? So if the element is present, then this part will take care of the result. But when there is a unsuccessful search, then that means when the element is not present in the list, then we need to display that key element is not found. So to check that one, I am comparing that I element, the index, with the size. If I is equal, when I reaches the size, when there is no element found in the particular list. So if I is equivalent to the size of the list, then only we will display this one. For example, if we are trying to, for example, if it is 5, 3, some 8, and then 6, and I am trying to check for 9. So is it present in this list? No. We'll traverse the entire list starting from 0 to 4. So we know that 5 will compare for 9 with 5, 3 with 9, 4 with 9, 8 with 9, 6 with 9. But that key element is not present. Then what it will do? It will go for the next iteration. Now I will become 5. But 5 is not less than 5. Here the loop terminates. By the time when the loop terminates, the value of I will be 5. So in that particular case, our I is equivalent to n. So here 5 is equivalent to 5. In that particular case, we are going to display that key is not present in the given list, or it is not present in the array. So this is how we are going to implement linear search using C programming language. Here we implemented linear search in two different languages and two different approaches also. In the first one, when we implemented linear search using Python, we used functions. But when we do the same thing in C language, without using functions, we try to find the linear. We try to find whether the element is present in the list or not. So we can do in reverse also. That means we can, without using functions, we can write the code in Python, as well as using functions using functions in C, we can write the program. Those two things are left as an exercise for the viewers. Those who are interested, they can implement linear search using functions in C language and without using functions in Python. Next. So as an extension of this particular topic, here in the previous code, in the previous example 56429, so here the list of elements are 56429 in the previous example. Now we will extend this linear search. Suppose if we want to find whether the given element is present more than one time or not, that is nothing but whether that element occurs multiple times, more than one time in a given list. So to check that one, we'll go with something like this: 52429. I want to check whether the key element 2 is present in the list or not. If the key element is 2, key element 2 is present in the list and present in the list more than one time. That means 2 times it appeared in the list. If you take 5, it appears only one time, like that. So now we are implementing code to check the multiple occurrences of a particular element in a given list. For that one, we will go with the same, the first part in C language, similar code. that is nothing but the size of the list, how many elements you want to store, what are the elements that we want to store, and what is the key element. Up to that point the code is same, there is no change. So that's why I have not included that part in this in this slide. So after getting here 7 numbers they have taken, the size is 7 and the list of elements are something like this. We will go with the same example. The list of elements are 1, 2, 4, 2, 2, 5, 8, 7 elements. 7 elements. So here the element 2 is present more than one time and it appeared for 3 times at different locations. It present in location 2, location 4 and location 5. That is what the output we got here. 2 is present at location 2, 2 is present at location 4, 2 is present at location 5. So and finally 2 is present 3 times in the array. This is the output that we should get. So now let us try to understand the code. So to count how many times it appears, to hold that particular value, we are declaring count is equivalent to 0. Initially the occurrence is 0. So after that we are checking whether that key element is present or not in the given list by writing this if statement. If array of I is equivalent to key, what is I? That is nothing but the current position, always starts from 0. So in this loop I is 0 initially, so array of I, array of 0 is equivalent to the key element or not. What is our key? 2. So is array of 0 is equivalent to key element? No. Then it will go with the second iteration, I will become 1. So when I is 1, array of 1 is equivalent to the key element. Yes. So previously when the current element matches the key element, there we are displaying a message that the key element is found at the so and so location and we will come out of the loop. But this time we are displaying some message and we are not breaking down the loop. We will continue with the next iterations for checking for its occurrence in the remaining part of the list. So here if the key element is equivalent to the current element, we are displaying a message that key element is present at location and here the location is I plus 1. So here 2 is present at location 2. That is what that is the output that we will generate by writing this if statement. So after displaying this first message, now it will increment the count variable. Previously count is 0. Now it will be 1. So after incrementing the count variable, it will go for the next iteration. It is not coming out of the loop. That is the major difference here. So it will go with the next iteration and now I is 1. When I is 1, now I is 2. If array of 2, that is 4. Now the current element is 4. Is 4 is equivalent to key? No, it will go with next iteration. So when I is equivalent to 3, when I is 3, is array of 3 is equivalent to the key element? Yes. There, when the current element equivalent to the key element, once again we are displaying the message that the key element is present at location I plus 1. So here 2 is present at location I plus 1, I is 3 plus 1 means 4. So key is present at location 4. This is first location, second location, third, 4, 5, 6 and 7. Indices means 0, 1, 2, 3, 4, 5 and then 6. This is index and this is location. So now our iteration is here. Now that key element is present at location 4. So after displaying that message, we are incrementing the counter. Now previously count value is 1, now it will become 2. So once again it will go further, it will go with the next iteration. Now the I value is 4. So once again we will check, is array of I is equivalent to key? Yes. So once again we are displaying 2 is present at location I plus 1, that is 4 plus 1, which is 5. And then we are incrementing the count value. Now count value is previously 2, now it is 3. And after that we will go further. Now the I value is 5. Now we will compare A of 5 with key. It's not a match. Once again it will go with next iteration. I value is 6. Is array of 6 is equivalent to key? No. Then it will go with next iteration. When it takes I as 7, it will come out of the loop. So now we will check the count value. If the count is 0, that means when the count 0 means the key element is not present in the list. So if that count is equivalent to 0, we are displaying the message as that key element is not present in the given array. But here our count value is 3. So we are executing the else part. So in that one we are displaying that key element 2 is present 3 times in the given array or in the array, simply in the array. So that is nothing but generating the last statement. So this is how we are going to check multiple occurrences of some element in a given list of elements. Suppose if we are checking for 9 instead of 2, if we are checking for 9 or 7, whatever it may be the number. Suppose if we are checking for 7. So in the iteration, when I takes from 0 to 6, all iterations will end up unsuccessful. That means we are not going to find the match between the current element and the key element. Then automatically the initial value, which is the initial value of count, will be the same. That is nothing but 0. So in that case, count will be 0, and we are going to display this particular statement, that is nothing but 7 is not present in the given list. So this is how we are going to check the multiple occurrences of a key element in a given list of elements. Same thing can be implemented using Python. So that is left as an exercise to the viewers. Now, what is the timing complexity and space complexity? Because every time whenever we develop or implement algorithms for some task, we'll check the time and space complexities. The time complexity for linear search is order of n. If the element is present in the last position, then it will take n different comparisons. So definitely the timing complexity may reach n. So that's why the timing complexity for linear search is order of n, and the space complexity is 1. Space complexity is nothing but the space used for storing extra variables. Here we are going to use the key, some count, some flag kind of things. If that key matches, we are going to display a successful search or else unsuccessful search. To hold that one, we use only one variable. So the space complexity here is order of 1. What are the applications of linear search? Where do we use this linear search algorithm? Linear search can be applied for both single dimensional and two-dimensional arrays that contain few elements. When the list contains some specific elements, not some specific, when the list is finite, when few elements are there, then we can apply linear search. And one more application is when the list is unordered, then we will go with the linear search. When the list is ordered, we can apply another searching technique, but especially when the list is unordered, we'll go with the linear search. But timing complexity for linear search is order of n, which is huge when the list is when the input is very large in size. That's why it will be considered as a limitation for linear search.
Like, share and subscribe. Hit the bell icon for more updates.